Hello, welcome back. This is Rupesh, and in this video also we are going to study some more problems, solve some problems based on whatever we have studied till now. And I request you to go through all the videos carefully so that actually there are no loopholes in whatever we are learning. Okay, so let's start with this first problem. Prove that sec square x plus cosec square x is equal to sec square x into cosec square x. I hope this is a very easy problem for you. So the proof is, so sec square x plus cosec square x, that is the LHS. So sec square x can be written as 1 upon cos square x, and cosec square x can be written as 1 upon sin square x. Let's cross multiply. So we have sin square x plus cos square x upon cos square x into sin square x. Now the numerator is equal to 1, right? That is the identity, cos square x plus sin square x, sin square x plus cos square x. So we have 1 in the numerator, so I can write the whole term as 1 upon cos square x into 1 upon sin square x. Now what is 1 upon cos square x? Sec square x, and 1 upon sin square x, cosec square x. Now that is our RHS. So good, we have solved this problem. I hope you understood it very quickly. Now prove that, next problem, prove that sec to the power 4x minus sec square x is equal to tan to the power 4x plus tan square x. Okay, so let's solve this. So the proof, LHS is sec to the power 4x minus sec square x. So what generally should come to our mind, let's take out sec square x common. So I take sec square x common, so we have sec square x minus 1. Okay, so what is the formula for sec square x? Sec square x is equal to 1 plus tan square x. So we are writing sec square x is equal to tan square x plus 1. If I write it here, so tan square x plus 1 minus 1, only tan square x will remain. Now let's multiply. So it is tan to the power 4x plus tan square x. And yes, that is RHS. So this problem is also done very quickly. Okay, let's move to the next problem. Prove that sin to the power 6x plus cos to the power 6x is equal to 1 minus 3 sin square x into cos square x. Now we have power 6 here. Now what comes to my mind is we should use the identity sin square x plus cos square x is equal to 1, because that is the identity we know, and we can start from there to solve this problem. But we have power 6, that means we have to take cube of that particular identity. So this is the identity, sin square x plus cos square x is equal to 1. So let's take cube on both sides. Okay, so taking cube on both sides, taking cube on both sides. So if we take cube on both sides, it is, so for this I'm assuming that you know this formula of a plus b whole cube. So a plus b whole cube is a cube plus thrice a square b plus thrice a b square and plus b cube. So here I am taking sin square x as a and cos square x as b, and we are writing this, right? So this is the formula, a plus b whole cube is equal to a cube plus thrice a square b plus thrice ab square plus b cube, right? So this is the formula, and you can go through this how we expanded this. Now sin to the power, so sin square x to the power 3 is sin to the power 6x. Then we have 3 into sin square x whole square. So from these two terms, okay, these two, the second and the third term, we can take out common 3 sin square x cos square x. So if I take that common, what will remain? Sin square x plus cos square x, right? From here, if we take 3 sin square x cos square x, 1 sin square x will be remain, and from here it will be cos square x remaining, and the last term cos to the power 6x. Okay, now this is equal to 1, right? Sin square x plus cos square x, this is equal to 1. This term is equal to 1. So we have sin to the power 6x plus cos to the power sin to the power 6x plus cos to the power 6x is 1, and we will send this term to the RHS, so it will minus 3 sine square x cos square x. This bracket is already 1, we don't need to write that. Okay, so this is the proof we have already. Okay, I hope this was also a very easy one for us. Now try this problem. So this is kind of let's say assignment for you. Try to prove this. Sine to the power 4x plus cos to the power 4x is equal to 1 minus 2 cos square x plus 2 cos to the power 4x. I would like you to pause this video for some time and try this. Okay. Let's solve one more problem. So there is this problem. Eliminate theta if x is equal to a sec theta and y is equal to b tan theta. Now, under some this kind of like if we have this kind of problems, try to visualize which identity we can use. So here we have sec theta and tan theta, and we know the identity that sec square theta minus tan square theta is equal to 1. So that is going to help us. So here x upon a is equal to sec theta and y upon b is equal to tan theta from the given. So x square upon a square minus y square upon b square is this what? Sec square theta minus tan square theta, and that is equal to 1. So this is what we have. X square upon a square minus y square upon b square is equal to 1. Okay. Somewhere later, or you might have already studied, this is equation of hyperbola. I'm not going to go into details of that, but this is how we solve this problem if we want to eliminate some terms. Okay. Now, the last problem for this session. If sec x plus tan x is equal to k, show that sin x is equal to k square minus 1 upon k square plus 1. Okay. So this is how I am going to approach this. Obviously, we can have different approaches. We know that sec square x minus tan square x is equal to 1. So left hand side have two factors, sec x minus tan x and sec x plus tan x, using a square minus b square is equal to a minus b, a plus b. So sec x minus tan x is what? See, this term sec x plus tan x, this is already given to be k. Then what is the value of this? This k will go on this side and we will get 1 by k. So sec x minus tan x is equal to 1 by k. Sec x plus tan x is equal to k. It is already given. Let's add. If we add these two, we get twice sec x. And if I subtract and do k minus 1 by k, it is going to be twice tan x. Okay. Now, what is k minus 1 by k upon k plus 1 by k? So we have already these values. It is 2 tan x upon 2 sec x. Now on the left hand side, okay, we will multiply numerator and denominator both by k. So we get k square minus 1 upon k square plus 1. Here 2 gets cancelled, 2 is not there. And tan x, we can write tan x as sin x upon cos x. And sec x is equal to 1 upon cos x. So cos x will be in the numerator, right? Here cos x upon cos x is equal to 1. And on the right hand side we have sin x. So now k square minus 1 upon k square plus 1 is equal to sin x. And in this way we have solved this. So proved. Okay. So in this video we have studied few more problems. I hope you will go through this carefully and try to solve more and more problems. Thank you very much.